Yeah, okay. Microphone's working. I think I got a few slides further, but I want to re-pick it up here. Okay. This, if I didn't mention it yesterday, is known as a Bohr diagram. So, quick bit of like recap on what Bohr discovered. Bohr realized that electrons seem to literally teleport from like here to here. They don't actually go around in circles and orbit. That's what Rutherford thought. Rutherford figured maybe they go around like the Earth goes around the sun or the moon goes around the Earth. He thought it went around in circles. There's actually a couple of reasons why he knew immediately that was false. I don't need you guys to know those reasons, but in case you care again, one of them was that things that go around in circle actually give off charges that goes around in circles, actually gives off radiation. And so in theory, if all matter had electrons that go in circles, if all matter had electrons going around in circles, it would give off radiation and we'd all be dying. So like Rutherford even knew he was wrong as he made his prediction. Another reason is that as electrons go around in circles, a prediction would be made that if this is a nucleus and electrons are going in circles, they would eventually lose their energy and spiral out of control and like collapse on the middle. And then all matter that we know it would actually like collapse on itself. And that doesn't happen either. So that's like physics 30. So don't memorize that by any means. But long story short, we know that they don't actually go around in circles. But Bohr made a prediction that they actually like literally hop from like this ring to this ring out here. And they teleport. And as far as we know, that seems to be true. And physicists are working on that as we speak, which is amazing. Okay, anyways, here's where I want to pick up our story. These things in the outermost ring, they were called valence electrons. And I think I would have written that down at some point last day. Valence electrons. And basically the concept is either you have almost a full ring and you want to like add one or two more to make it full, or you want to like ditch the extra one you've got. For example, everybody in this row number 1 here is all going to have a +1 charge. And the reason is they all have like one extra electron in this outer ring. And it kind of like wants to get rid of it. And say, rather than having one too many, here, somebody else take it. Over here, everybody in like group 17 usually has a -1 charge. And the reason why is they've got like 1, 2, 3, 4, 5, 6, 7. There's like a spot right here. It'd be great for an electron. I could use an electron. Or this guy right here could use an electron. Okay. Now, one of the things we mentioned last day is, can you change the number of protons something has? No. If you change the number of protons something has, that actually makes it something completely different. That's what its name is based on. Okay. So like, I cannot add more positive stuff. But imagine that I had, say, 8 protons, and I was supposed to have 8 electrons. But let's say that for some reason, I gained an electron. I now have 9 electrons. Well, now this thing would be called an ion. And ions have a charge to it. And so all you got to figure out is, what is there more of? Is there more positive or more negative? And if there's more negative, then it would be a -1 charge. Or let's say that you had 8 protons and you had 8 electrons. If it's the same, the name for that is an atom. But let's say this guy loses an electron and now there's only 7 electrons. Now what does it have for a charge? If it loses an electron, there's 8 protons but only 7 electrons. Who wins? Positives or negatives? Positives. How much does it win by? By 1. So this would have a +1 charge. Now, things do not become positively charged because they get more protons, though. Remember, protons are positive? You can't get more protons and change its charge. Okay. I actually have a silly little analogy that I use to try to help describe this sort of like valence electrons being gained and lost. Imagine that you went to the store and you had to buy something. And just for the sake of argument, let's say that the thing costs $8. Okay. Let's say that that's what the item costs. That's my analogy. Okay. Well, look at the outer ring over here for fluorine. How much electrons does fluorine have? It has 1, 2, 3, 4, 5, 6, 7. Fluorine has 7 in its outermost ring. Does fluorine quite have enough money to make it to 8? Not quite yet. It's close, though. Now, let's approach somebody else over here. So that's like someone in this column here. Let's say we take lithium right here. Lithium has like a full inner ring, but inner rings don't even count. And in its outer ring, how many electrons in the outer ring? Well, it has 1. Well, isn't this like the greatest of setups? If something costs $8, You've got 7 and you've got 1. Well, what do 7 and 1 add up to? 8. Here's what happens. This is actually how bonds form, is that this guy is going to give his electron over here to this guy. And now, well, this guy will have 8. And this guy will now be like empty. But like empty is actually good. If you just get rid of your outermost ring, then at least you don't have like one excess something sitting there. Like there's like an excess electron growth just sitting here it wants to get rid of. Okay. We have names for these things. We call those ions. So this I think is where I kind of lost time last day. Yeah. It doesn't. Like basically the way that we see that matter works is that it always starts with the outer ring, and then it could actually work its way down. But as soon as it finds like a stable orbit, which means that like it's full, then there's no desire for it to gain or lose electrons. So anything that's like an inner ring is considered full. And it's remember we talked about inert gases or inert materials? That would be a good example of these ones right here. This guy right here has a full outer ring. It doesn't want to gain or lose electrons. Right. So hydrogen actually, if you guys have your periodic tables nearby, hydrogen actually can be either +1 or -1. The reason why is it could either gain 1 more electron and have 2 electrons and be full, or it could ditch the electron and have 0 and be empty. Basically, you either want to be empty or full, never halfway in between. Okay, so here's the terminology I need you guys to know. Atoms are neutral. Okay. Atoms have protons equaling electrons. But here's the thing. Many atoms then have like an extra electron, or they need another one, right? You're the friend that has $7 and you got to go bum $1 off your buddy because like you're close, but like you need an extra dollar. Like you go to the cafeteria and you want to buy, I don't know, you buy chocolate milk at the cafeteria and you're 25 cents short. So you go find your friend, can you give me a quarter, right? It's that exact same scenario where someone just needs a little bit extra or someone has a little bit extra. And in that case, now you have ions. Because ions have either gained a little bit extra or given something away. And these now have charges. Yeah?
Another easy way is because the ion, I don't know if a lot of people use this, but it's don't.
Okay.
So the way I remember it is since ion means don't, it doesn't add up.
So don't in that it does not add up. Okay, that's good. Yeah. Here's a couple more slides, and then I want to get to the practice one that I really hop to at the end here. So here's a good example of a positive ion. I'm going to use sodium as an example. Sodium has 11 protons and 11 electrons as an atom. But if I were to draw it out, it would look something like this. Okay? The first ring gets 2 electrons. That's ring number 1. The second ring gets 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 2 in the first ring, 8 in the second ring. It means I need a third ring. Well, I need 1 electron there, right? Because 2 plus 8 plus 1 gives me the 11. Sodium is just overshot the mark by just a little bit too much. It's like the person who has an extra quarter lying around. And so what sodium would really love to do is ditch this electron and say, I'm going to get rid of you. Well, now what does that mean? Well, it still has 11 protons, but now there's only 10 electrons. What is there more of, protons or electrons? Protons. How many more protons? 1. Therefore, sodium has a 1 plus in the corner. We don't usually write with a 1 there. We just write a plus sign. But some things can have I'll use calcium. Calcium can actually have 2 positives. Or aluminum can have 3 positives. It really depends on how many electrons you either have more or less of. Okay? We call that a cation. Okay? Anything positive is a cation. And a student years ago back in my old school came up with a really clever way of memorizing this. I want to share it. If you want to know which one is negative or positive, cats have paws. Maybe you heard this somewhere. Cats have paws. So cations are positive. Actually kind of clever. I don't know whether he learned it somewhere, but he told me and I thought it was brilliant. Here's the opposite of those. These are anions. Anions have negative charges because they want to take extra electrons. I want to draw out chlorine for us. Chlorine has 17 protons because it's number 17. If I were then to kind of draw out its rings, we call these orbitals still. 2 electrons in the first orbital, 8 in the next, 1, 2, 3, 4, 5, 6, 7, 8. We're going to need another ring. Sorry, I'm kind of running out of room there. This would be, what was I at? 8? No, I was at 10. 9, 10, 11, 12, 13, 14, 15, 16, 17. I got room right here. Right, this is the guy who goes to the cafeteria, wants to buy something, and is just short. Okay. So what he's going to do is he's going to try to find an extra electron, and he's going to like suck an electron into him and add one more that's not normally there. Well, now he's got 18 electrons and 17 protons. What happens to its charge? Well, electrons wins, right? There's one extra electron, so it gets a negative charge, and we call that an anion. And again, you can write the 1 afterwards if you want, but we don't normally do that. This is actually how compounds form, and you probably know this, I'm hoping, because this was actually grade 9. But when sodium with a positive charge and chlorine with a negative charge come into contact with each other, positives and negatives attract. This makes NaCl, and you guys might know this as salt. So, anyways, that's kind of my notes here. I want to now do some examples. Oh, I got a few more things here. The word we use is called ionized. So when things become ions, we call them ionized. And it's possible to have more than one type of ion. Some things can be like, say, +1 or +2. There's some weird exceptions out there. And then this right here just talks about how we usually want to have 8 electrons in a stable energy level. But why don't I skip ahead? Let's try this example, because this is really like, this is the doing that I need you guys to be able to accomplish. So I think I did like one of these last day. Let's try to finish the rest of these off, and then we'll do our activity. What I need you guys to be able to do based on this information is predict like what we call this atom or ion. So like right off the bat, we did this first one, 17 protons. We should be able to know what name we give something with 17 protons. Who's number 17 on your table? I believe it's chlorine. So we're going to call this chlorine. But then we need to know what isotope of chlorine it is. And we put a little dash afterwards, and there's going to be a number that comes next. And it tells us how heavy it is. Okay. For some perspective, you would need over 1,000 electrons to weigh a proton or a neutron. They are so tiny in comparison. So really all we care about is what the first 2 columns of protons and neutrons add up to. 20 and 17 is 37. So this is known as a chlorine 37. That's how heavy it is. The last thing we need to do is figure out whether it is an atom or an ion. And if it is an ion, what sort of charge it has. So now we want to consider the protons and electrons columns. Are they the same? No. So it's not an atom. It is now an ion. The question is, well, what sort of charge does it have? Well, then just do like some mental math. 18 is bigger than 17 by 1. And since there's more electrons, it is a -1 ion. Does that make sense? So I've got 4 more examples just to kind of work through. We'll try some of these. And that's actually all I want to go to for like our quiz. Oh, I got to show you one more thing. We sometimes write this with a different notation, just so you've seen this. Sometimes we go chlorine. We put a 17 in the bottom corner, because 17 is what protons it has. And we would put a 37 up in the top corner, because that tells you how heavy it is total with the neutrons. And then we would put a -1 up here. That would be like a shortened notation for it, just so you've seen that. Let's try another one. Start with the 10 protons. If you have 10 protons, what do we call you? Who's number 10 on the table? Okay, so neon. Okay. Then we want to talk about how heavy neon is. Okay. Now, neon has to have 10 protons, but it can actually have any number of neutrons. Neutrons are neutral, so like you could have 4. You could have 17, you could have 6. Okay. So we just need to know how many there are, and so 10 plus 11 means we're going to call this a neon 21. That's how total heavy it happens to be. Let's call this like atomic mass. And then the last question is an atom or an ion? And since there's 10 protons and 10 electrons, it looks like it's equal. So we're going to call it an atom. I don't need to put a charge on it. Its shorthand notation would look like this. Neon with a 10 in the corner, a 21 up top. And since there's no charge, I don't put anything in this corner here because it's neutral. This is an atom. Does anybody have any questions? Is this somewhat familiar? Maybe not exactly everything, but like Remember talking about this sort of stuff at some point in grade 9? I'm hoping I'm seeing some nods, but okay. Okay, so 7 protons. Who is number 7? Is that nitrogen? Nitrogen. Okay, so now I know who we call you. We call you nitrogen. Now, these next 3 I'm going to do all at once if I could, because the next one below it is also nitrogen. And the one below it is also nitrogen. And I know that because they all have 7 protons. These are called isotopes of each other, if that word comes up, isotopes. Isotope means it's the same proton molecule, but like it has different weights to it, right? Like this one is going to weigh 15, because 8 and 7 is 15. This one is going to weigh 16, because 7 and 9 is 16. And this one is also going to weigh 16, because 7 and 9 is 16, right? So isotopes just mean they have different weights to them. That's all. It's the same thing. And then for the last question, we just got to figure out atoms versus ions. So 7 protons and 7 electrons makes you an atom. 7 protons and 7 electrons, still an atom. Hey, 7 protons and 8 electrons means that there was 1 extra electron, making it a 1 minus ion. That's all I've got. The next slide, basically, if you do scroll to it in your notes here, has a whole bunch of like words and definitions that when you're studying, if you study, I don't need you to study, guys. Tomorrow's quiz is really just let's see where you're at, okay? But like if you do want to look over some of these words and be like, do you know what I'm talking about here when I ask these things? Okay. For example, like mass number. Mass number would be this number right here, the 37. It tells you how heavy it was, or the 16. That's a mass number. So, does that make sense? Cool. Okay, I'll pause my